Welcome to another tutorial. This week we're going to do a cool Python exercise. I have built this sample model, you can see, and I'm going to show you how you can use recursion to develop a parametric networking structure like this. So I've also created some parameters here that can control how this structural configuration could work, or how many networks we want it to have. And you can also control the radii of the elements. So it's kind of like a fibrous structure, right? So that's kind of the essence. And we're going to do this from scratch. So let's see if we will achieve what we want to do. And I'm going to actually create a new sketch. So do a quick intro on Python. So for Python, you need to go to mat script, and you need this plugin to be installed so that you can run the Python module. Or if you're working in Run, you can go to Tools, Python script, edit. This will exactly work the same way, but we can also convert it to Grasshopper as well. So if you load this up, what you need to do is you double click, and inside you actually have the script functions imported. So if you do import Rhino script syntax as rs, then every time you call an rs function dot, you can call a Rhino function. So for instance, if I want to add a point, I can do rs.addPoint, and here I can basically give the xyz for the point, and we close it up, and it will run the script. The problem is it doesn't output it, and the output is labeled as a here. So if I do a equals rs.addPoint test and hit OK, now you can see that that point is being created. So you can actually write your own custom plugin this way, and I can also make it points as well. So you can do points and rename this script. So that variable basically stores that point, and this plugin outputs it. And we imported the Rhino script syntax as rs so that we can run Rhino functions. So for instance, if I do point, this is basically the add point function, and it asks you to choose a location. It's exactly the same way. It's like a command prompt. Now what I want to do for this exercise is start creating a point grid. So we want to, of course we can do it as an input here. There are a lot of point grid options, but I want to show you somehow like how we can control this within the same plugin. So we want to have essentially two planes, so one plane here at the bottom and one plane on top, and we want to be able to draw, we want to be able to first divide a point grid, generate point grids on these, and then connect those point grids. So that will be the first step, and then we're going to do this in a recursive manner so that we can add more elements as we go. So let's start creating a point grid. So first thing I want to, while I'm inside here, I can actually do this as I think as a for loop, right? So we can actually do it as a for loop. So I'm going to type in for x in range, let's say 0, comma num points. Let's define a variable, and we're going to do let's actually make this as a single for loop. So this would, let's say this is 10, then I'm going to do print x, right? So if I do a test, you can see that this defines a range. This defines a range that starts from 0 and goes all the way up to 10, and it outputs the x. And if I were to do, for instance, define points as a list, then I can do here, let's move this up here, and do points dot append, which is to add to that list. I want to create this point, but I want its x to be the x dimension, right? So this is x, y, z, and I want to create an empty list. These brackets symbolize the list function, and the parentheses is for the for normal function calls, and this is for the list. And I'm going to add inside the for loop, I'm going to add 10 points. So when I do a test, it doesn't print anything. But here you can see it outputs into the point list. Now we have a row of points basically. Now I'm going to turn it into a grid. To do that, we need two nested for loops. So if I do for x in range 0 to 10 and for y in range 0 to 10, and I'm going to indent this line using the tab, and we can do xy now and do a test. Now that will give me a 2D grid basically, and we can customize these functions if we want. To create the second loop on top, I can simply copy this line and here type in, let's say 50, and hit test. Let's see, hit tested, okay. This should actually work. This should actually work, but let's see. Points test, okay. It's creating 2 points. It's all the way on top. It was out of my screen, I couldn't see it. So let's make it 20 and hit test. So there it is, right? So we can basically create two separated point grids, but the problem is these are contained within the same list, and we want to be able to access them individually or separately. So I want to essentially create two lists that are at two different planes, and I want to create lines between them. So you can see that this is pretty much repeating, so why not define it as a function, so that we can define point grid as a function, and then I can use two parameters for this, basically the number of points and maybe the step size as well. So we can do num, and then we can do step as two parameters. And then if I were to input it here, then we can create an empty list inside this function. And then these could be num, right? So they are going to be parameters. So these are the parameters of the function. So they will be inputs, and I can use those inputs inside the function, inside the for loop. And then this is basically the interval for those points. So this could be x times step, and this could be y times step. And we want to append not to the points, but to the list, right? And then we want to output. I'm actually going to zoom into this a bit more so that we can see. And then out of the for loop, we're going to do return list. So how is this going to work? I'm going to call this function with two parameters, and inside that function, I'm going to create an empty list and do a double for loop using this variable, which defines the number of points in the x and y direction. And then we're going to also control their intervals. So step controls their interval, their spacing. And we're going to create points at corresponding grid locations, and we're going to append or add them to this empty list and return the list, so that we can do something else afterwards. So I can call this function here. For instance, we can do 3 points, and step is, let's say, 2. Oh, we can also control maybe the z, right? So we can also probably control z. And let's actually make this points equals point grid, and we don't have to make it as a list there anymore. So let's try if this works, and there it is. So this basically function outputs 3 by 3 grid separated at the interval of 2. And you can actually define these as parameters. So we can maybe call this as dx. Sorry, so let's make this dx, distance x, and nx as number x, right? So these are inputs. I gave them some variable names, and then I can rename this here. So if you zoom in here, you can customize the inputs. You can add or remove them. You can also right click here and make this an x and make this dx. And we want these to be, one of them has to be integers. So the nx is numbers of x, numbers in the x direction. So we can make this, let's say, from 0 to 10. We don't need it to be too large. And the spacing, we can actually make it all the way up to 5 with some decimals. And let's go in, let's do a test. Okay, so we have to define some parameters. So let's test this, hit OK. Let's see what's not working. We can actually check it here, solution exception. Range must be an integer. So this nx has to be an integer as an input. So in order to do it as an integer, we right click here, go to type hint and make it an integer. And there it is. So this is our grid. I can actually control its dimension and I can control its spacing. So I basically wrote the function that can create a 2D grid. And we can also add another parameter here. Let's call it z, and let's make this 30. So let's say that I want to create 2 sets of grids. So this is grid A. So we can do grid A, and I can do grid B, and I can also copy these parameters here, and let's call this this was nx actually, so we can maybe do it na da nb db, right? So those will be my parameters, and we can output these as well. So we can do grid A here. These have to be identical, otherwise you will have issues. So you need to make sure that you're writing up the text the same way. And we need these to be the same names as well, so that it will work. So this is DA, and I can make copies of these two, add more parameters here, and call these N and B and DB. I'm trying to keep them as simple as possible. And let's see, test. So range integer must be an integer. So this guy, again, this we need to type hint and set it to be an integer. And there it is, our 2 grids, but they're at the same height. And I want this z to be the total height. So maybe we can input a third parameter here. This could be 0 and this could be z. And I can control it here. So maybe we can do h. We can use a different parameter there, because inside the function you can actually receive a parameter and rename it something else. And if I do a test, now grid A and grid B are working, and I can control its total height. I can control the type width. I can control the numbers over here and over here. This is perfect. So we can actually work with these outputs and we can draw lines through them. But what I want to do is somehow create a randomized function inside, and I want to be able to draw curves actually. So one way to do that is let's block these away. So these define my grids, the point grids. And inside, what I want to do is develop a function that connects these two grids. So we can first do let's say connect grids and pass in grid A and grid B to this function. And we can also maybe we can actually do this separately. We don't need a function there. So maybe we can just do, maybe we can just do a for loop or while loop. So if I were to do a while, like a recursive function, we can actually do while true, and inside we need a break condition. So while true, you need something to be looping here until some condition is met where it stops. So here it will be if some condition, if let's say count is, let's say, greater than 20, then we do break. This is important because if you don't write a break function inside the while loop, and if you don't, for instance, keep numbers of the count, let's say I here make a count variable which is 0, and inside I need to increment count plus 1, and let's say we print a message, print count, right? And I'll do this 10 so that we can see if I do a test, you can see that that count is being printed out. it starts as, sorry, we actually increment it here, so we can do this in the beginning, and then we can do a test, and you can see it's printing out 10, and then it breaks the while loop. So this is a recursive loop, so it loops until some condition is met. And that condition could be anything we want. What we want is, maybe we want some random connections between these two grid lines. So to be able to do random connections, we need to import random library as well. So we can do import random, and we can call it as R&D, or you can just say random as well. It doesn't matter. So we import random, and inside, rather than printing count, we want to do something here. So we can do something, and that could be, we actually draw random lines between these 2 points, right? So we can do a equals random dot choice. We want to choose a point from grid A list, and we want to do a random choice from grid B, and we just want to draw a line. So we can do L, so we can do rs.add line. Add line, let's start with a straight line, A and B, A comma B. And we want to be able to store these lines now. So here I can create a list, call it lines equals an empty list. And I want to add lines to this empty list. So we can do lines.append, rs.add line. And that lines list could be the output as well. So here, if I create lines and look at it as curves, let's see, it says null, lines that append, rs.add lines. This should be okay. Let's do a test. There it is. So these are the random lines that we create. So, but every time I change the grids, you can see that those lines are changing as well. And what I want to do is maybe fix those, fix these lines. Actually, I may not be able to do it, because even if I fix seed for the random, I think because we are running these functions multiple times, I think it will still generate new lists. But let's see, maybe we can do here. Actually, if I change these parameters, it will just completely randomize the whole thing. So maybe we keep it as it is. So it's always randomized. That's actually the essence of today's exercise. So what I want to do is turn these to curves. So rather than doing straight lines, I want to do interpolated curves. So we can do that by adding a curve. So we can do lines. So let's do C equals, or let's actually add the curve, rs.add curve. And for the curve, we need 4 points. But the way I want it to be is a Bezier curve. So the bottom point, I want it to move it a bit up. So it's like, let's say there's a point here. I want that point to move up a bit, so that that point is here. And then if there's a point on top, let's actually make a copy. Let's actually show what I'm trying to do. And then that point is here. Then I can move this point down as well. And if I were to draw a curve through these points, you can see that the deviations for this curve are pointing upwards, and that's what we want. So we need these 2 additional points. So I can rename them as C or A2, for instance, if we want to create another point, which is A moved up. And then we can do rs.move object. So here below, you can actually see what that function does. So it needs an object ID, and it needs some translation to move an object, and it returns identifier of the moved object if successful. We can also do, rather than moving object, we can actually do rs.pointAdd, and we can add a point and a vector together. I think that would be better. So we can displace A by some amount in Z direction. So let's say that direction is 10. So I define a vertical vector, And we can do the same for B, but I want this to be negative. Okay. And then when I want to add a curve, I can put these points in a list. So we go from A to A2 to B2 and then to B finally, and then close this list. And that could be a NURBS curve now that we are looking at. Let's see if this would work. And rather than adding these, let's append this curve to the lines list and see what we have. So if I do a test, there's a syntax error at line 27. It says lines. Oh, this has to be lines that append. So I forgot to write it. And there it is. So we can control the end deviation as well. What if we actually control this as a parameter? So let's call it dev. And then I input another input here, dev. And then let's make a copy of this. And I can control the end deviation, but you can see that it's kind of hectic a bit because every time it's creating a new grid. Maybe we can actually fix it. So what if we actually do, before here, we can do random.seed and just give it a stable seed like 0. And then we do test. Now I can actually show you how the deviation affects the distribution of these elements. Right, so that's the height, that's the grid dimension as well, and those are the number of points. If I change the number of points, the structure changes because it needs to find out where to connect the elements. So that's essentially headed in the right direction. And the next thing I want to do is a bit more advanced. So you're warned basically for the next step. So what I want to do now is to make random connections between these lines, right? And I want those to be curves as well. So how can we do that? We can basically do, if I go down, I can write another while loop, basically. And we can actually do, let's actually make this more compact. I can also control the number of elements here, but I'm going to do it later. So this outputs lines, right? So these lines, and maybe I want to create some random connections between those lines. So one way to do that would be to create a list. Let's see. So I'm going to copy this while loop again, and this time I want to get a point at a curve, on a curve. So that could be, we might have to actually write a function for that. So let's see. Let's say that I want to a equals get random point on curve, and then we want to give the list lines. Actually, we want to get a curve here, right? So we want to be able to choose a curve, and we want to get a random point on that function. So the way this is going to actually, let's think about this. So we need to choose a random curve and then get a random point on that curve, and then do this operation twice. So we need to do this twice, and then we want to draw a line between those two, and that's what we want to do. So we know how to choose a random curve, which is basically random.choice. We don't have a function to get a random point on a curve yet, so we need to build it. So we have to do it on top. So if I do definition get our random point on curve, and we need to feed in curve here. So we will pass a curve here, and it will give us a random point on that curve. And for that one, we actually first need to find the domain of the curve. So domain would be rs.curve domain, curve. And then we want to basically return a point. So we can do evaluate curve, I guess. So return rs.evaluate curve. Let's see what that does. we use a curve ID and a t parameter, and it returns the 3D point if successful. So we can do curve, comma. Domain normally returns you an interval, so there will be two parameters in there, which will be 0 and 1 index. So I want to manipulate the 1 index times random dot random. When you call random, it's a float between 0 and 1. So this will be the total length, total domain of the curve, and we are going to get a random percentage of it basically, and we're going to return it as a point. So I'm going to first draw straight lines so that we start from there with the while loop. So this gives me a random point on a curve, and below here we first need to choose a random curve and get a random point on that curve. So we can actually do it by, let's see, while true, choose a random curve. Let's say a equals random.choice, and we do lines. Now we are operating on lines, and then we do point a equals, we can call the name of this function get random point on curve, and pass in a, pass in that curve. So this will be for a, right? Now I want to do the same thing for the second one. I can just copy this and rename this as b and input the parameter as b, and then we can add a new connection. Let's call it let's create a new list here. We can also append to the lines list actually, which would be interesting. So we can keep building it. Lines.append rs.addLine a comma b, right? And we need to increment count, and we want to break it when 10 is met. I think this would do it. So let's do a test. It says there's an error with, oh, this can't be a and b, it's point a and point b. My mistake. So let's, because point a and b are the curves, point a and point b are the points. And there's, I only got one though, because I think count is already 10 by this point. So because I'm using the same variable, I can actually make it 0 here. Do a test. Now you can see that it's building up straight lines, right? So these are the lines. Those are some of the connections that are being drawn as lines. The problem is, if it's on the same curve, then technically I'm drawing a straight line on the same curve, because random.choice can actually pick the same curve twice. That seems like an issue actually. So we might have to develop a way of fixing it, but I know I'm kind of going out of the way here, but maybe we can actually make it a bit more interesting. So let's see. So rather than doing this is actually working, but rather than picking the same curve, I'm looking at my notes. Let's see. Maybe we can do something a bit more interesting. So we can do choice. We can do append. I guess we need two lists that are separate. So we can actually, we have a global list that are lines. So the first list comes out as lines. So then we can essentially, let's see, let's keep two lists. One is a global list and one is a list that we can operate on. Maybe we can do that. So we can, for instance, here do, I think, lines, or we can do, let's see, we can rename it as anything we want. We can actually call it curves equals lines that copy. I think we can copy that list, and when we are doing choice here, we can actually remove from lines that remove a, so that second random choice wouldn't have this curve in it, right? So that will eliminate that option. And we can keep appending the new curve into the list, but we also need to add it to curves.append. And we need to separate this now, so we can rename it as L equals that, and then I put it here and here. So the reason why I'm doing two curves is lines list gets updated, so we are removing some items from it because we are adding some more curves, but this curves list will be global. So every curve that we create, it will be added to that list. And oh, list has no attribute copy. So maybe we can do, can we do it? Actually, let's make it here, curves equals like open empty list and add it to there as well. So C equals rs.add curve and C, and see, this is kind of the old way. I think there should be a way of copying it, but maybe that's not the keyword. So build it, that's it, test, hit OK. Now I need a curves here as well. So you can see the curves would be the whole elements. Why cannot I see it? So let's see, curves that append C, and that's good. Lines that remove A, that's fine. So let's do a test, and there it is. So the lines list, you can see, is getting down in numbers, but the curves list is keeping track of all the curves that we need. So that's good. Now we need to make these curves and then basically finish the thing. So we can get in, and rather than adding a line as a straight line here, rs.add line, maybe we can make these as Bezier curves, right? So like the curves that we drew here first, maybe we can actually make them a bit more interesting. So we are getting random points on a curve, but we are not getting the vectors. Maybe we need the vectors. So one way of getting the vectors would be to evaluate not the curve, but get a perpendicular frame on the curve. So if I do return rs.get rs.curve perpendicular frame, I can actually evaluate the curve at that location, and that will return to me a frame. And the frame normally has an origin and XYZ direction embedded into it too. So this will return a collection of things. So basically, in the second while loop, what I can do is I choose a random curve, then I remove it, and then I get a random point on curve. This is actually a perpendicular frame now. So this point A variable so this point A variable now contains an origin. So if I do origin for both of those, the script will work exactly fine, the same way. But now we also have a Z direction, and we can use that as a variable too. So like the add curve here, I can actually probably build a way of doing it. I'm actually going to just write it up here so that it's more simple. So we can do L equals rs.add curve. So the way this should go is, actually, let's make it so we get the point A origin, and then we need a C and a D, or A2 and B2. So A2 would be point A origin moved along the Z-axis of the perpendicular frame on point A, right? So yeah, so that will be rs.point add, and we want to do point A dot origin, comma point A dot Z-axis, and we want to actually multiply this a bit. So how do we multiply that? Let's see. We can do vector scale. Yeah, we can do the vector scale. So I can do rs.vector scale point A Z-axis, comma, let's give it a magnitude. So we could do like 15, and that will give me A2. Now B2 would be something similar, so we can just copy this line. Point B origin, and point B Z-axis minus 15, right? And then we can do, we can now define L, which could be L equals rs.add curve, add curve, and we need to define an array here, A, A2, B2, and B. Now let's see when I do test, expected float got UID line 57. So this guy here, this is, oh, this has to be point A dot origin, right? So this has to be point A dot origin. This is point B dot origin. So those are the points. And there it is. Wow. So it's 15. 15 is a bit too much. So maybe we can call it a parameter called V for the vector and add it here. So V, we can also rename them as anything we want, but let's reduce this so you can see these are the connections. Now, something kind of technical, which is you can see the second points are sometimes grabbed towards the top of the curve and the first point is at the bottom. That's why we're getting this kind of like a figure is coming backwards. And to fix that, you can actually customize the interval a bit. So when you're choosing a random point, random curve first, and then you're getting a random point on a curve, you might want to have a function inside here that kind of gives you an interval. So we might want to actually evaluate that curve from the bottom half of the line, right? So let's say if the curve length is 0 to 1, for point A, we want to get it up to 0.5. And for point B, we want to get it up from 0.5 to 0.5 to 1 maybe. So we can probably define some interval. So rather than doing get random point on curve, here we can actually feed in two sets of parameters. So we can define that interval. And you can actually say, like, you can give it a true or false here. So for instance, this is true. And let's say this is false. So when it's true, these are two new parameters that I added. And then here you can say under curve, we can look for that condition. And we can check if condition, if it's true, we want the random R to be within, let's say this times R. We want the random to be between a threshold that we define. So we can do that by using uniform. And if it's true, it means we want it from the bottom half. So we can do 0 to 0.4, let's say. And else, if it's false, then we want R to be between kind of an upper threshold. So we can do 0.8 to, 0.6 to 1. Yes. So if I call this function with true, I will get a random point below the midline of the curve. If it's false, I'll get a point above the midline of the curve, right? So this will give me two random points. So when I do a test, that's basically the end result. And you can see that this point is kind of moving here. I can also make it a bit more upwards, right? So we can do, if I change these thresholds, we can also put new inputs for these. Let's do this as 65, this is 35. And do a test. So we can increment them a bit more. And this end deviation now, we can also customize it a bit. Okay, so that's actually the tutorial. I mean, we can also control the number of connections. So maybe connections, let's call it NC. For the NC could be this parameter here, how many networking connections you want. So you can input them here directly. And then we can also control total number of curves. So num curves could be here. You can rename them any parameter names you want. I haven't been too efficient with the with these parameters, but yeah, so that's a lot actually. So the first set of curves, we can maybe reduce them to be like 10. The second, we can increase or decrease, right? So you can see it's getting a lot of complex behavior. So we can do it like that. That's okay. And when we have these, then you can also do something interesting. So you can actually take mirrors of those. So we can first mirror it using the YZ plane. so that you can get a copy of it to the other end, and you can pipe them. So you can pipe both of those, and that will give you something like that. So it tends to work better with symmetry. And we can hide these. So now let's play around with it a bit. So we can change the number of points on top, the spacing at the bottom. We can change the dimension of the grid, the number of points, that this is controlling the top. This controls the total height, so we can increase the height of it. This controls the deviation for the first set of curves. This controls the deviation for the second set of curves. This controls the number of additional connections. This controls total number of first curves, right? So that's in essence what we have created. So it's kind of looking like a Gothic portal now. So that's what it looks like. Okay, and I'll bake it too so that we can see it. There it is. I hope this was interesting. So we're going to do another session next week on Python, look into more recursive growth and do branches. So stay tuned. I hope you like this type of creative content. So I'll appreciate it if you also subscribe to the channel. And thanks for watching.